podcast on Chapter 25 of your textbook, Phylogeny and Systematics. Make sure you write down the heading before moving on. Alright, first we're going to have a little bit of a review here. In the last podcast we talked about taxonomy and how taxonomy can be used to classify or organize all of life into different systems. And the greatest or largest system that we use is the domain, and in this particular diagram it shows that down at the bottom. So we've got the domain down there. Oops. Back up. Okay, try that again. So again, down here at the bottom is our domain. We're going to be classifying this leopard up here. Gotta get rid of that. Okay, so this is what we call the divergence then, we were just talking about. So each branch point represents the divergence of two species. So that's definitely something you want to label in your notes. I'll make sure we get this part erased. You can start writing that down. So on your little diagram of your phylogenetic tree, so maybe you did something like that. Like that. This one goes up to here. Okay, so label each one of your branches a divergence between two different species. Again, they went down different evolutionary paths at that point. Okay, so now that you have that labeled, let's just look a little more closely at what that means, that divergence. So again, we've got a phylogenetic tree here. Just a quick, real, example that won't hopefully take too long. We've got a common ancestor, like I talked about, at each of these points. We diverge in two different directions. One of these divergences ends up leading to a wolf. Remember, there are a series of ancient organisms that no longer exist, but today we have wolves as a result of that divergence. Down here we have a second divergence between leopards and cats, and that divergence was more recent than the second divergence. So I'm just trying to point out this point here, that the deeper branch points, so let me just kind of highlight for you what that deeper branch point might mean. So this area right here, okay, is a deeper branch point than this area right here. And those deeper branch points represent progressively greater amounts of divergence. Okay, so the deeper the branch point, the more different or the more divergent those areas were. Okay, so while you're writing that down, I'm just going to erase some of this. Again, you already have your diagram of your phylogenetic tree, so you don't need to draw another one, but you do want to make this little point here on the side that the deeper branch points represent greater amounts of divergence. Alright, moving along. So, important words here are in red and nice and big. You want to make sure you understand them. Maybe listen for a minute before you actually write them down. We were talking about phylogenetic trees, and the basis of any phylogenetic tree is called something called a cladogram. And the cladogram really picks up on patterns of shared characteristics. Okay, so what you're looking for is a section of a phylogenetic tree that has a certain pattern. Okay, and that pattern is contained in what's called a clade, which is a group of species that includes one ancestral species and all its descendants. Okay, so if we kind of work our way up here, maybe an easier way to understand that is that a clade builds a cladogram which again is the basis or the building blocks of the, let's just circle it here, phylogenetic tree. Okay, so we're just working our way up here. Smaller part clade in the middle of the cladogram, the larger structure or symbol is the phylogenetic tree. So why don't you take a minute to write down the important parts of that while I erase this. Okay, so here's an example of a cladogram, and hopefully you can see how this is just a smaller version or a piece of, a chunk of a phylogenetic tree. So again, the clade we're looking at here is just giant pandas. Okay, so the group that included the common ancestor of giant pandas and other pandas and things that we have today. And here's the giant panda, the current day organism. But we're also showing its other relatives, red pandas, raccoons, bears, and then, like I said, its common ancestor right down here. You can see all these divergent points that led to the relatives of the giant pandas that we have today. So this is a cladogram, again, and the whole group is called the clade. So the giant panda, its common ancestor, and all its relatives. You may want to draw this in your notebook just as an example. Okay, again, some bolded red words here that you want to make sure you get into your notebook. Again, I'll try to highlight what the important things are, and then we'll look at an example of it on the next screen. Oh, got to do some erasing. Gives you some time to write here. Okay, shared primitive character is shared beyond the taxon we're trying to define. So this is some sort of trait. For example, if you think of a character as a trait, that all of the organisms in your clade have, but there are also other organisms that are not in the clade that have it. Okay, so it's beyond the taxon. And it's a primitive character, meaning that that trait came or showed up before that clade actually evolved. Again, I'll show you an example of this in a minute. Hopefully it'll make a little more sense. Now the shared derived character is unique to a particular clade. So this is a trait, again, that did not show up until that clade or that group evolved. Okay, derived, again, is the key word here. So derived is a new trait, whereas primitive is an old trait that existed before the clade existed. So hopefully that makes sense. Again, I'll give you an example here in just a moment.